Hi, welcome to our channel of IGNOU Audiobooks, Indira Gandhi National Open University School of Vocational Education and Training, SOVET. Master of Science, Information Security, MSCIS. Semester 2, MSEI 026, B, C, P, Doctor Planning Audit. Block-1 Risk Analysis, Unit 3 Risk Analysis Techniques and Methodologies. 3.0 Introduction. There may be some terminology and definition ranges related to risk analysis, risk assessment and business impact analysis. Although several definitions are possible and can overlap, for purposes of this article, please consider the following definitions. A risk analysis involves identifying the 11-10 probable threats to an organization and analyzing the related vulnerabilities of the organization to these threats. A risk assessment involves evaluating existing physical and environmental security and controls and assessing their adequacy relative to the potential threats of the organization. A business impact analysis involves identifying the critical business functions within the organization and determining the impact of not performing the business function beyond the maximum acceptable outage. Types of criteria that can be used to evaluate the impact include customer service, internal operations, legal, statutory and financial. Most businesses depend heavily on technology and automated systems, and their disruption for even a few days could cause severe financial loss and threaten survival. The continued operations of an organization depend on management's awareness of potential disasters, their ability to develop a plan to minimize disruptions of mission-critical functions, and the capability to recover operations expediently and successfully. The risk analysis process provides the foundation for the entire recovery planning effort. A primary objective of business recovery planning is to protect the organization in the event that all or part of its operations and/or computer services is rendered unusable. Each functional area of the organization should be analyzed to determine the potential risk and impact related to various disaster threats. 3.1 Objectives. After studying this unit, you should be able to define risk analysis, how to analyze risk, describe the methodologies to assess, analyze risk, and identify risks and its methodologies. 3.2 Risk analysis. Regardless of the prevention techniques employed, possible threats that could arise inside or outside the organization need to be assessed. Although the exact nature of potential disasters or their resulting consequences are difficult to determine, it is beneficial to perform a comprehensive risk assessment of all threats that can realistically occur to the organization. Regardless of the type of threat, the goals of business recovery planning are to ensure the safety of customers, employees, and other personnel during and following a disaster. The relative probability of a disaster occurring should be determined. Turns to consider in determining the probability of a specific disaster should include, but not be limited to, geographic location, topography of the area, proximity to major sources of power, bodies of water and airports, degree of accessibility to facilities within the organization, history of local utility companies in providing uninterrupted services, history of the area's susceptibility to natural threats, proximity to major highways which transport hazardous waste and combustible products. Potential exposures may be classified as natural, technical or human threats. Examples include natural threats, internal flooding, external flooding, internal fire, external fire, seismic activity, high winds, snow and ice storms, volcanic eruption, tornado, hurricane, epidemic, tidal wave, typhoon. Technical threats, power failure, fluctuation, heat engine, ventilation or air conditioning failure, malfunction or failure of CPU, failure of system software, failure of application software, telecommunications failure, gas leaks, communications failure, nuclear fallout, human threats, robbery, bomb threats, embezzlement, extortion, burglary, vandalism, terrorism, civil disorder, chemical spill, sabotage, explosion, war, biological contamination, radiation contamination, hazardous waste, vehicle crash, airport proximity, work stoppage, internal, external, computer crime. All locations and facilities should be included in the risk analysis. Rather than attempting to determine exact probabilities of each disaster, a general relational rating system of high, medium and low can be used initially to identify the probability of the threat occurring. The risk analysis also should determine the impact of each type of potential threat on various functions or departments within the organization. A risk analysis form, found here, PDF format, can facilitate the process. The functions or departments will vary by type of organization. The plural MNING process should identify and measure the likelihood of all potential risks and the impact on the organization if that threat occurred. To do this, each department should be analyzed separately. Although the main computer system may be the single greatest risk, it is not the only important concern. Even in most automated organizations, some departments may not be computerized or automated at all. In fully automated departments, important records remain outside the system, such as legal files, PC data, software stored on diskettes or supporting documentation for data entry. The impact can be rated as 0 equals no impact or interruption in operations, 1 equals noticeable impact, interruption in operations for up to 8 hours, 2 equals damage to equipment and or facilities, interruption in operations for 8 to 48 hours, 3 equals major damage to the equipment and or facilities, interruption in operations for more than 48 hours. All main office and or computer center functions must be relocated. Certain assumptions may be necessary to uniformly apply ratings to each potential threat. Following are typical assumptions that can be used during the risk assessment process. 1. Although impact ratings could range between 1 and 3 for any facility given a specific set of circumstances, ratings applied should reflect anticipated, likely, or expected impact on each area. 2. Each potential threat should be assumed to be localized to the facility being rated. 3. Although one potential threat could lead to another potential threat, e.g. a hurricane could spawn tornadoes, no domino effect should be assumed. 4. If the result of the threat would not warrant movement to an alternate sites, the impact should be rated no higher than a 2. 5. The risk assessment should be performed by facility. To measure the potential risks, a weighted point rating system can be used. Each level of probability can be assigned points as follows. Probability points: high 10, medium 5, low 1. To obtain a weighted risk rating, probability points should be multiplied by the highest impact rating for each facility. For example, if the probability of hurricanes is high, 10 points, and the impact rating to a facility is 3, indicating that a move to alternate facilities would be required, then the weighted risk factor is 30, 10x. 3. Based on this rating method, threats that pose the greatest risk, e.g. 15 points and above, can be identified. Considerations in analyzing risk include: 1. Investigating the frequency of particular types of disasters, often versus seldom. 2. Determining the degree of predictability of the disaster. 3. Analyzing the speed of onset of the disaster, sudden versus gradual. 4. Determining the amount of forewarning associated with the disaster. 5. Estimating the duration of the disaster. 6. Considering the impact of a disaster based on two scenarios. A. Vital records are destroyed. B. Vital records are not destroyed. 7. Identifying the consequences of a disaster, such as A. Personnel availability. B. Personal injuries. C. Loss of operating capability. D. Loss of assets. A. Facility damage. 8. Determining the existing and required redundancy levels throughout the organization to accommodate critical systems and functions, including A. Hardware. B. Information. C. Communication. D. Personnel. A. Services. 9. Estimating potential dollar loss. A. Increased operating costs. B. Loss of business opportunities. C. Loss of financial management capability. D. Loss of assets. A. Negative media coverage. F. Loss of stockholder confidence. G. Loss of goodwill. H. Loss of income. I. Loss of competitive edge. J. Legal actions. 10. Estimating potential losses for each business function based on the financial and service impact and the IENGTH of time the organization can operate without this business function. The impact of a disaster related to a business function depends on the type of outage that occurs and the time that elapses before normal operations can be resumed. 11. Determining the cost of contingency planning. 3.3. Evaluating and managing risks. Almost everything we do in today's business world involves a risk of some kind. Customer habits change, new competitors appear, and factors outside your control could delay your project, but formal risk analysis and risk management can help you to assess these risks and decide what actions to take to minimize disruptions to your plans. They will also owe you to decide whether the strategies you could use to control risk are cost-effective. Here we define risk as the perceived extent of possible loss. Different people will have different views of the impact of a particular risk. What may be a small Risk for one person may destroy the livelihood of someone else. One way of putting figures to risk is to calculate a value for it as risk equals probability of event x cost of event. Doing this allows you to compare risks objectively. We use this approach formally in decision making with decision trees. To carry out a risk analysis, follow these steps. 3.3.1 Identify threats. The first stage of a risk analysis is to identify threats facing you. Threats may be human, from individuals or organizations, illness, death, etc. Operational, from disruption to supplies and operations, loss of access to essential assets, failures in distribution, etc. Reputational, from loss of business partner or employee confidence or damage to reputation in the market. Procedural, from failures of accountability, internal systems and controls. Organization, fraud, etc. Project, risks of cost overruns, jobs taking too long, of insufficient product or service quality, etc. Financial, from business failure, stock market, interest rates, unemployment, etc. Technical, from advances in technology, technical failure, etc. Natural, threats from weather, natural disaster, accident, disease, etc. Political, from changes in tax regimes, public opinion, government policy, foreign influence, etc. Others. This analysis of threat is important because it is so easy to overlook important threats. One way of trying to capture them all is to use a number of different approaches. Firstly, run through a list such as the one above, to see if any apply. Secondly, think through the systems, organizations or structures you operate, and analyze risks to any part of those. See if you can see any vulnerability within these systems or structures. Ask other people, who might have different perspectives. 3.3.2 Estimate risks. Once you have identified the threats you face, the next step is to work out the likelihood of the threat being realized and to assess its impact. One approach to this is to make your best estimate of the probability of the event occurring, and to multiply this by the amount it will cost you to set things right if it happens. This gives you a value for the risk. 3.3.3 Manage risks. Once you have worked out the value of risks you face, you can start to look at ways of managing them. When you are doing this, it is important to choose cost-effective approaches. In most cases, there is no point in spending more to eliminating a risk than the cost of the event if it occurs. Often, it may be better to accept the risk than to use excessive resources to eliminate it. Risk may be managed in a number of ways. By using existing assets. Here existing resources can be used to counter risk. This may involve improvements to existing methods and systems, changes in responsibilities, improvements to accountability and internal controls, etc. By contingency planning, you may decide to accept a risk, but choose to develop a plan to minimize its effects if it happens. A good contingency plan will allow you to take action immediately, with the minimum of project control if you find yourself in a crisis management situation. Contingency plans also form a key part of business continuity planning, BCP, or business continuity management, BCM. By investing in new resources, your risk analysis should give you the basis for deciding whether to bring in additional resources to counter the risk. This can also include ensuring the risk. Here you pay someone else to carry part of the risk. This is particularly important where the risk is so great as to threaten your or your organization's solvency. 3.3.4 Review. Once you have carried out a risk analysis and management exercise, it may be worth carrying out regular reviews. These might involve formal reviews of the risk analysis or may involve testing systems and plans appropriately. Risk analysis allows you to examine the risks that you or your organizations face. It is based on a structured approach to thinking through threats, followed by an evaluation of tile probability and cost of events occurring. Risk analysis forms the basis for risk management and crisis prevention. Here, the emphasis is on cost effectiveness. Risk management involves adapting tile use of existing resources, contingency planning and good use of new resources. 3.4 Decision Tree. Decision trees are excellent tools for helping you to choose between several courses of action. They provide a highly effective structure within which you can lay out options and investigate the possible outcomes of choosing those options. They also help you to form a balanced picture of the risks and rewards associated with each possible course of action. 3.4.1 Drawing a decision tree. You start a decision tree with a decision that you need to make. Draw a small square to represent this towards the left of a large piece of paper. From this box, draw out lines towards the right for each possible solution and write that solution along the line. Keep the lines apart as far as possible so that you can expand your thoughts. At the end of each line, consider the results. If the result of taking that decision is uncertain, draw a small circle. If the result is another decision that you need to make, draw another square. Squares represent decisions and circles represent uncertain outcomes. Write the decision or factor above the square or circle. If you have completed the solution at the end of the line, just leave it blank. Starting from the new decision squares on your diagram, draw out lines representing the options that you could select. From the circles, draw lines representing possible outcomes. Again, make a brief note on the line saying what it means. Keep on doing this until you have drawn out as many of the possible outcomes and decisions as you can see, leading on from the original decisions. An example of the sort of thing you will end up with is shown in Fig. 1. Look at the screen. Fig. 1. Example decision tree. Once you have done this, review your tree diagram. Challenge each square and circle to see if there are any solutions or outcomes you have not considered. If there are, draw them in. If necessary, redraft your tree if parts of it are too congested or untidy. You should now have a good understanding of the range of possible outcomes of your decisions. 3.4.2 Evaluating your decision tree. Now you are ready to evaluate the decision tree. This is where you can work out which option has the greatest worth to you. Start by assigning a cash value or score to each possible outcome. Estimate how much you think it would be worth to you if that outcome came about. Next, look at each circle, representing an uncertainty point, and estimate the probability of each outcome. If you use percentages, the total must come to 100%. At each circle, if you use fractions, these must add up to L. If you have data on past events, you may be able to make rigorous estimates of the probabilities. Otherwise, write down your best guess. This will give you a tree like the one shown in Fig. 2. Look at the screen. 3.4.3 Calculating tree values. Once you have worked out the value of the outcomes and have assessed the probability of the outcomes of uncertainty, it is time to start calculating the values that will help you make your decision. Start on the right hand side of the decision tree, D, work back towards the left. As you complete a set of calculations on a node, decision square or uncertainty circle, all you need to do is to record the result. Here you can ignore all the calculations that lead to that result from then on. 3.4.4 Calculating the value, uncertain outcome nodes. Where you are calculating the value, if uncertain outcomes, circles on the diagram. Do this by multiplying TL, a value of the outcomes by their probability. The total for that node of the tree is the total of these values. In the example in Fig. 2, the value for new product, thorough development, is 0.4, probability good ORTCO.NE, x $1 million, value, equals $400,000. 0.4, probability moderate outcome, x $50,000, value, equals $20,000. 0.2, probability poor outcome, x $2,000, value, equals $400, $420,400. 3.4.5 Calculating the value of decision nodes. When you are evaluating a decision node, write down the cost of each option along each decision line, then subtract the cost from the outcome value that you have already calculated. This will give you a value that represents the benefit of that decision. Note that amounts already spent do not count for this analysis. These are sunk costs and despite emotional counter-arguments, should not be factored into the decision. When you have calculated these decision benefits, choose the option that has the largest benefit and take that as the decision made. This is the value of that decision node. 3.5 Risk Analysis Methodologies. 3.5.1 Qualitative Risk Analysis Methodologies. In this section, we will deal with the qualitative methods used in risk analysis, namely preliminary risk analysis, PHA, hazard and operability study, HAZOP, and failure mode and effects analysis, FMEA, FMECA. 3.5.1.1 Primary risk analysis. Preliminary risk analysis. Preliminary risk analysis or hazard analysis is a qualitative technique which involves a disciplined analysis of the event sequences which could transform a potential hazard into an accident. In this technique, the possible undesirable events are identified first and then analyzed separately. For each undesirable events or hazards, possible improvements or preventive measures are then formulated. The result from this methodology provides a basis for determining which categories of hazard should be looked into more closely and which analysis methods are most suitable. Such an analysis also proved valuable in the working environment to such activities lacking safety measures can be readily identified. With the aid of a frequency consequence diagram, the identified hazards can then be ranked according to risk, allowing measures to be prioritized to prevent accidents. 3.5.1.2 Hazard and Operability Studies, HAZOP. The HAZOP technique was developed in the early 1970s by Imperial Chemical Industries Limited. HAZOP. Can be defined as the application of a formal systematic critical examination of the process and engineering intentions of new or existing facilities. TG assesses the hazard potential that arises from deviation in design specifications and the consequential effects on the facilities as a whole. This technique is usually performed using a set of guide words: no, not, more, less of, as well as, part of, reverse and other than. RRJM. These guide words, scenarios that may result in a hazard or an operational robbery identified. Consider the possible flow problems in a process line. The guide word more of will correspond to high flow rate, while that for less than low flow rate. The consequences of the hazard and measures to reduce the frequency with which the hazard will occur are then discussed. This technique had gained wide acceptance in process industries as an effective tool for plant safety and operability improvements. 3.5.1.3 Failure Mode and Effects Analysis, FMEA, FMECA. This method was developed in the 1950s by reliability engineers to determine problems that could arise from malfunctions of military system. Failure mode and effects analysis is a procedure by which each potential failure mode in a system is analyzed to determine its effect on the system and to classify it according to its severity. When the FMEA is extended by a criticality analysis, the technique is then called Failure Mode and Effects Criticality Analysis, FMECA. Failure mode and effects analysis has gained wide acceptance by the aerospace and the military industries. In fact, the technique has adapted itself in other forms such as misuse mode and effects analysis. 3.5.1.4 Discussion and Conclusion. The three techniques outlined above require only the employment of hardware familiar personnel. However, FMEA tends to be more labor-intensive, as the failure of each individual component in the system has to be considered. A point to note is that these qualitative techniques can be used in the design as well as operational stage of a system. All the techniques mentioned above have seen wide usage in the nuclear and chemical processing plants. In fact, FMEA, one of the most documented techniques in use, it has been used by Intel and National Semiconductor to improve the reliability of their products. For the case of preliminary risk analysis, it has seen application in safety analysis in both industry and on offshore platforms. HAZOP, on the other hand, has been widely used in the chemical industries for detailed failure and effect study on the piping and instrumentation layout. 3.5.2 Tree-based techniques. In this section, fault tree analysis, FTA, event tree analysis, ETA, cause-consequence analysis, CCA, management oversight risk tree, MOT, and safety management organization review technique, SMOL-T, will be discussed. 3.5.2.1 Fault tree analysis. The concept of fault tree analysis, FTA, was originated by Bell Telephone Laboratories in 1962 as a technique with which to perform a safety evaluation of the Minuteman Intercontinental Ballistic Missile Launch Control System. A fault tree is a logical diagram which shows the relation between system failure, i.e., a specific undesirable event in the system, and failures of the components of the system. It is a technique based on deductive logic. An undesirable event is first defined and causal relationships of the failures leading to that event are then identified. Look at the screen. Fig. 5. A fault tree depicting the event, fire breaks out. Fault tree can be used in qualitative or quantitative risk analysis. The difference in them is that the qualitative fault tree is looser in structure and does not require use of the same rigorous logic as the formal fault tree. Fig. 5 shows a fault tree with top event, fire breaks out. This method is used in a wide range of industries and there is extensive support in the form of published literature and software packages, such as CARA. An application of fault tree analysis on causal relations for large vehicle accidents is documented in 3.5.2.2 Event tree analysis. Event tree analysis is a method for illustrating the sequence of outcomes which may arise after the occurrence of a selected initial event. This technique, unlike Fault tree uses inductive logic. It is mainly used in consequence analysis for pre-incident and post-incident application. The left side connects with the initiator, the right side with plant damage state. The top defines the system's nodes, dots, call for branching probabilities obtained from the system analysis. If the path goes up at the node, the system succeeded; if down, it failed. ETA has seen application in the nuclear industries for operability analysis of nuclear power plant as well as accident sequence in the 3 Mile Island 2 reactors accident. 3.5.2.3 Cause-Consequence, N-lysis. Cause-Consequence Analysis, CCA, is a blend of fault tree and event tree analysis. This technique combines cause analysis, described by fault trees, and consequence analysis, described by event trees, and hence deductive and inductive analysis is used. The purpose of CCA is to identify chains of events that can result in undesirable consequences, with the probabilities of the various events. In the CCA diagram, the probabilities of the various consequences can be calculated, thus establishing the risk level of the system. Fig. 6 below shows a typical CCA. Look at the screen. This technique was invented by Riso Laboratories in Denmark to be used in risk analysis of nuclear power stations. However, it can also be adapted by the other industries in the estimation of the safety of protective or other systems. Details on how to carry out cause-consequence analysis as well as the benefits and restrictions of it are documented in literature. 3.5.2.4 Management Oversight Risk Tree. Management Oversight Risk Tree, MORT, was developed in the early 19,705 for the U.S. Energy Research and Development Administration as safety analysis method that would be compatible with complex, goal-oriented management systems. MORT is a diagram which arranges safety program elements in an orderly and logical manner. Its analysis is carried out by means of fault tree, where the top event is damage, destruction, other costs, lost production or reduced credibility of the enterprise in the eyes of society. The tree gives an overview of the causes of the top event from management oversights and omissions or from assumed risks or both. The MORT tree has more than 1500 possible basic events input to 100 generic events which have been increasing identified in the fields of accident prevention, administration and management. A generic MORT diagram is included at the end of this report. MORT is used in the analysis or investigation of accidents and events and evaluation of safety programs. Its usefulness was cited in literature. Normal investigations revealed an average of 18 problems and recommendations. Complementary investigations with MORT analysis revealed additional 20 contributions per case. 3.5.2.5 Safety Management Organization Review Technique MIT. Safety Management Organization Review Technique, SMORT, is a simplified modification of MORT developed in Scandinavia. This technique is structured by means of analysis levels with associated checklists. While MORT is based on a comprehensive tree structure, owing to its structured analytical process, SMORT is classified as one of the tree-based methodologies. The SMORT analysis includes data collection based on the checklists and their associated questions, in addition to evaluation of results. The information can be collected from interviews, studies of documents and investigations. This technique can be used to perform detailed investigation of accidents and near misses. It also served well as a method for safety audits and planning of safety measures. 3.5.2.6 Discussion and conclusion. The tree-based methods are mainly used to find cut sets leading to the undesired events. In fact, event tree and fault tree have been widely used to quantify the probabilities of occurrence of accidents and other undesired events leading to the loss of life or economic losses in probabilistic risk assessment. However, the usage of fault tree and event tree are confined to static logic modeling of accident scenarios. In giving the same treatment to hardware failures and human errors in fault tree and event tree analysis, the conditions affecting human behavior cannot be modeled explicitly. This affects the assessed level of dependency between events. No doubt, there exists techniques such as human cognitive reliability to reconcile such deficiencies in the fault tree analysis. New methodologies that model such responses have emerged. 3.6 Qualitative risk analysis. Methodology. Risk analysis can be broken down into two broad methods, and these methods are qualitative and quantitative. The qualitative method for risk analysis is designed for the purpose of enhancing one's awareness of potential problems and can assist one in analyzing these risks. Quantitative risk analysis is designed so that the security measures can be implemented, and this will allow the cost envelope to be implemented as well. There is yet a third method for risk analysis which is used, and this is referred to as being the hybrid method, since it borrows characteristics from both the quantitative and qualitative risk analysis methods. Of the three approaches, the qualitative analysis is the most simple to use and is therefore used the most often. Qualitative analysis is useful because it allows one to quickly identify potential risks, as well as assets and resources which are vulnerable to these risks. Not only does qualitative analysis showcase the safety measures that have already been utilized, it will show those which could be useful if they are implemented. The goal of qualitative risk analysis is to gain a level of risk protection which is acceptable and one which will increase awareness among the necessary members of the organization. This analysis will often make use of calculations which are fairly basic, and it is often not necessary to know the value of all the assets in question, while quantitative analysis does many of the same things which can be found with qualitative analysis. It is also capable of identifying the envelopes for which both safeguards and losses can be found. It is based on a process which is highly subjective, and it uses metrics that require it to have a high level of effort put into it. At the same time, quantitative analysis is capable of presenting data in a manner which is friendly for management, and VHL 11C pick I, U, N lugase values as well as probabilities. Now that we've gone over the two primary tools which are used for risk analysis, it is next important to learn a little bit about the methodology which is associated with them. One piece of methodology that you will want to familiarize yourself with is the scope statement. The scope statement is one statement which is designed to define the things that must be evaluated, as well as state the form of risk analysis that will need to be performed. The scope statement must also be capable of giving the results which have been expected. The next piece of methodology which is important to learn is called asset pricing. The information system will be defined based on the scope statement, and it will be further split into components which may be priced. While you have the option of splitting the system into smaller pieces, some say it is easier to simply take apart the entire unit, leaving on the components which are tangible. The tangible components tend to be those which are easier to price. One good example of tangible components is the telecommunications tools that the organization uses. These include tools which are internal as well as external. Any device which is used for communication purposes will need to be included in this category. Some devices which are great examples of this include both modems, routers, and telephones, as well as intercom or PA systems. After communication tools have been considered, the next thing which must be taken into consideration is the software devices. This includes any type of software which must be programmed. Operating systems should be the first thing to come to mind. Once you have incorporated everything related to software and software applications, you next need to consider the physical equipment. The physical equipment will include things such as monitors, computers, and computer terminals. Any object which is used for the purpose of displaying information must be considered. Printers should be included in this list, along with disk drives and memory cards. Power supplies should be factored in as well. Any systems which are designed for the purpose of holding data, such as error logs, usage logs, or info related to schedules, will need to be factored in the system as well. 3.7 Risk Breakdown Structure. When planning a project to meet targets for cost, schedule, or quality, it is useful to identify likely risks to the success of the project. A risk is any possible situation that is not planned for, but that, if it occurs, is likely to divert the project from its planned result. For example, an established project team plans for the work to be done by its staff, but there is the risk that an employee may unexpectedly leave the team. In project management, the risk management process has the objectives of identifying, assessing, and managing risks, both positive and negative. All too often, project managers focus only on negative risk. However, good things can happen in a project, things that were foreseen, but not expressly planned. The objective of risk management is to predict risks, assess their likelihood and impact, and to actively plan what should be done ahead of time to best deal with situations when they occur. The risk management process usually occurs in 5 distinct steps: risk management, planning, risk identification, risk analysis, risk response planning, and risk monitoring and control. The central point of risk identification and assessment in risk management is understanding the risk. However, this is also where project Managers and risk subject matter experts, SMEs, get the least help from recognized references, best practices, or work standards. Currently, the Project Management Institute, PMIR, has a team of SMEs working on a practice standard for risk management. This team has identified one very good tool, the Risk Breakdown Structure, RBS. The RBS helps the project manager, the risk manager, and almost any stakeholder to understand and therefore be able to identify and assess risk. 3.7.1 What is a breakdown structure? The RBS will prove extremely valuable to better grasp when a project needs to receive special scrutiny, in other words, when risk might happen. The RBS can also help the project manager and the risk manager to better understand recurring risks and concentrations of risk that could lead to issues that affect the status of the project. Following the concept of the work breakdown structure, WBS, the risk breakdown structure provides a means for the project manager and risk manager to structure the risks being addressed or tracked. Just as PMI defines the work breakdown structure as a deliverable-oriented grouping of project elements that organizes and defines the total work scope of the project, the RBS could be considered as a hierarchically organized depiction of the identified project risks arranged by risk category. Many project managers and risk managers currently use homegrown methods for listing, identifying, assessing, and tracking risks in their projects. These methods include spreadsheets, listing, generic risk taxonomy, based somewhat loosely on various standards and guidelines, an approach that simply places the risks in a list, a simple table, or even in a database does not provide the strength of using a structured, organized method similar to a work breakdown structure. To fully understand the risks and better identify and assess the risk, a deep dive into each risk, recording as many levels of identification as necessary, may be required. The project value of placing risks in a structure such as this lies in the ability of the project manager and risk manager to then quickly and easily identify and assess the risk, identify the potential risk triggers, and develop a more robust risk response plan. All risks are placed in a hierarchical structure as they are identified and the structure is organized by source. The total risk exposure to the project can be more easily understood and planning for the risk more easily accomplished. 3.7.2 Using the risk breakdown structure. The RBS serves as more than just a database for identifying risks to the project. When created, the RBS provides a vehicle for risk analysis and reporting and risk comparison across projects. Most importantly, the RBS is the tool for risk identification. 3.7.2.1 Risk identification. Risk identification will be the first step in determining which risks may affect a project. Identification also provides documentation of the risk characteristics. The first level, level 1, of the RBS can be used as a sanity check to make certain that all topics that might include risk are covered during the risk identification process. Using the RBS, an iterative process can be initiated that will persist throughout the project life cycle. The frequency and applicability of this iterative process will be different in each phase of the life cycle. Using a risk identification checklist that is focused on the RBS, using levels 2, 3, and below, assists in identifying specific and generic risks. This checklist can then become a part of the project manager's and risk manager's tool set for future projects. Risk identification leads to quantitative risk analysis conducted by the project risk manager. Interestingly, sometimes merely identifying the risk will suggest the proper response, which can be entered into the risk response plan. 3.7.2.2 Risk analysis, qualitative risk analysis. Risk analysis is more easily achieved if, after identification, the risks are placed in proper perspective within the RBS by categorizing the risks in the various levels. Risk analysis, quantitative risk analysis, involves the use of techniques for prioritizing the risk, determining the probability of the risk, and calculating the impact of the risk. At no point should the project manager or risk manager decide that the total number of identified risks should cause the cancellation of the project. The total number does not take into account the probability with which the risk will occur, nor the impact to the project, should the NSK occur. A few risks, with high probabilities and high impact, are far more critical to the overall success of the project than a large number of risks with low probability and minimal impact. Using the RBS, the project manager and the risk manager should create a risk score based on the priority, probability, and impact of each risk, and with each Group of risks, according to the appropriate level of the RBS. Using the RBS also offers other valuable understanding into the analysis of the identified risks. Some of these new understandings are: risk exposure type, dependencies between risks, root causality of risks, most significant and least significant risks, correlations between risks. Another benefit of the RBS is the ability to focus risk responses to the high probability, high impact, high priority risks using the risk topic groupings. Effective risk management demands that the project manager and risk manager fully understand the risks of a project. A successful risk management process would also require a good knowledge and understanding of the business objectives of the project. During risk identification, a large volume of risks can be identified. Simply listing these risks or putting them in a spreadsheet or database does not provide the in-depth understanding of the identified risks necessary to allow a solid risk response planning task. The RBS provides the tool necessary to assist in identifying risks, analyzing risks, and creating a successful risk response plan, and it provides a vehicle for deep dives into the complexity of the risk. OSINT's a hierarchical RBS, similar in its design to the WBS, allows the project and risk managers the opportunity to carefully align the risks in proper categories, using as deep an analysis as time and resources would permit. 3.8 Summary. Risk analysis is a systematic approach to determine specific risk events and their consequences. This approach helps in calculating risks. The risk analysis can further be categorized as qualitative risk analysis and quantitative risk analysis. Risk analysis can be carried out by sequence or steps to provide an appropriate risk treatment. Risk assessment is considered as the overall process of risk analysis and evaluation. This risk assessment cycle provides step-by-step process to deal with risks in a project. This process can further be categorized as quantitative risk assessment and qualitative risk assessment. The behavioral aspects of risk management are considered to support innovation and help to develop business. The personal bias in risk management depends on a person with his or her experience, culture, value, as well as education. The schedule risk estimates have good knowledge on sources of estimates and determine the high-risk dependencies. The resource risks are determined as these risks affects the development of the project, and the early identification helps to meet the project objectives on time. Thank you for listening. We will be back with the next chapter.